All right. Oh, I don't know how long Shelley didn't get sound here, but this is like a multi-person process, right? One person's got the voltmeter and they put the probe here and they're looking for the spot that says 1.75 volts. They find it here. Their buddy takes a pencil, puts a mark there. They move the probe until they find 1.75 volts again. 0.75, thank you. Their buddy puts a mark here. So you end up with a lot of dots everywhere where there's 1.75 volts, or 0.75 volts. Then pick a different voltage, say 2 volts, or 0.2 volts. So your probe, you measure 0.2 volts here. And then you move the probe and you find 0.2 volts here. And you move the probe and you get 0.2 volts here. And then don't assume that the pattern's going to look identical on the top. So it annoys me when groups only measure in the bottom half of the plate and then assume that the top half looks the same. That would be in a perfect world. That's not physics labs. So you're connecting these dots, right? So this is the data you're going to collect with your voltmeter. All these are your voltmeter measurements. And so you're going to have equipotential surfaces. And I think the lab specifies how many of these you need to have. I'm not sure what it is. Does someone... I don't remember how many I specified that you need to have. I think it was like 7 or 9 or something. So whatever it is, that's how many of these different voltage lines that you need to measure. So that's your data collection. If you get that far and you guys feel that your data looks good, you can leave. When you go home, though, you need to interpolate the electric field lines, and the only information you know is that the electric field is always perpendicular. So you can draw in what the electric field should look like based on your equipotential surfaces. Since your data is going to be on this paper plate, so one team member could take home the plate, or you guys could go upstairs to the library and photocopy the plate, or take a really good picture with your phone so that you can read all these voltage measurements. And so your final lab is going to have an actual photo, either a scanned image of your plate or a photograph of your plate with the drawn in equipotential surfaces and equipotential lines. Down here you're going to have a key. So if we added our equipotential lines, maybe I'll put that in green, or sorry, E-field lines. All right, so this is what your final lab should have in it, okay? If you want to recreate this on your computer, you can, but I really want to see the actual photo of your data that you took in class as well. Are there any questions about like how this is happening, or I'm sure you'll have questions as you start. Yeah, Vicki?
More about procedure though, because when I was reading this, I know it said you might have a clear plate, but we're going to have paper plates. But then it says, you know, mark those locations and transfer to graph paper. That's
yeah, so that was when I was
when
I at the beginning of class was like, darn it. So I was going to bring in these clear dishes, and that they're bigger, so you have more room to do this. And then if you have a clear dish, then you can put graph paper underneath and then follow the grid, and then on a separate sheet of graph paper you can mark on that graph paper all the voltages that you measure on that grid. And that ends up with a cleaner results, and you have more room to work. But unfortunately I forgot my Pyrex dishes, so we've got paper plates that we're going to use instead. So
like we don't have to transfer it.
no, so, yeah, so the nice thing about the paper plate is,
Where you are and stuff.
yeah, you don't. Yeah, so the nice thing about the paper plate is whatever you write on the plate, that'll be your end results. So make sure you can read it. So sometimes ballpoint pens will write through the water. A good pencil, make sure like it's got dark lead so that everyone can see it after it's photocopied. But that's all you have to do.
One picture of the end.
Yeah.
And then each person will write.
Yeah, so you'll leave the lab with the red lines on here, and then at home on the picture you're going to add your own E-field lines and key. Yeah. All right, so the voltage, the voltmeters are in the top drawer, sort of behind Leanne. The paper plates are kind of behind where Vicky's sitting, and there's battery holders. If you guys want to use 9 volts instead of 1.5 volts, you might have an easier time taking data. So there's some 9 volts down here in my, there might be some back there too. So it's entirely up to you what batteries you choose to use, and I'll help you jerry-rig these experiments together. All right, and